Hey everyone, we're going to practice our derivative shortcuts some more in this, but I also want to see what it looks like to try and take derivatives from a table instead of an algebraic function representation. And we should talk about the second derivative today as well. Yeah, that's the derivative of the derivative. Remember, acceleration, while it is the derivative of velocity, since velocity is the derivative of position, acceleration is actually the second derivative of position. So we'll come back and talk about the rate of change of the rate of change, but a little later. Right now, let's take a look at some practice. Please find y prime in each case. Okay, 1. Y equals 5x squared. 5, 4, yes, you have plenty of time. 3, 2, 1. Did you say 10x? Because you brought the 2 down, 2 times 5 is 10, and you subtracted 1. Okay, 2. Y equals 5x squared minus 2x plus 3. Please find y prime. 5, 4, 3, 2, 1. We brought down the 2 times 5 is 10x. The derivative of this linear function is 2, and the derivative of a constant is 0. Okay. So, or think about this as a constant times a function. I'm taking the derivative of a function and multiplying that derivative times that constant. I'm taking the derivative of x to the first, which is 1, and multiplying it by that constant. And the derivative of this constant is 0. Okay, number 3. How about y equals x to the pi? 5, 4, 3, 2, 1. Sure, this is just pi x to the pi minus 1. It's just a power rule thing. What about y equals pi to the pi? What's y prime there? 5, 4, 3, 2, 1. You don't see any variables there. No, that's pi to the pi. Pi to the pi is a number. A constant, the derivative of a constant is 0. Okay, watch out for that. All right, how about this one? 5. Y equals 3x to the third minus 4x squared plus 5x minus 10. Please find the derivative of that. 5, 4, 3, 2, 1. 9x squared minus 8x plus 5 is my derivative. Derivative of 5x is 5. I brought down the 2. I had negative 8x to the first. I brought down the 3 and subtracted 1. 3 times 3 is 9. Okay, we're starting to warm up here. So then how about y equals 3x to the minus 2 plus 7x to the minus 1 plus 3. Y prime. 5, 4, 3, 2, 1. So use that power rule. Negative 6x to the subtract 1 plus, use that power rule, negative 7x subtract 1, and the derivative of this is 0. Okay, what about this one? Y equals ax to the third plus bx squared plus cx plus d, where a, b, c, and d are constants. Please find y prime. 5, 4, 3, 2, 1. Excellent. 3ax squared plus 2bx plus c is my derivative. Okay, so how about this one? Y equals 3x squared plus 2x minus 1 over times x minus 4. Please find y prime. Five, 4, 3, 2, 1. Okay, so I'm using the product rule. This times the derivative of that. The derivative of x is 1. The derivative of a constant is 0. Plus that times the derivative of that. The derivative of this will be 6x. The derivative of this will be 2. All right, there's y prime. I don't see any GCF to factor out. So in chapter 5, I would probably have to FOIL and distribute combined like terms and then refactor. Hopefully we won't see much of that. What can you do with this one? 3x over 2x plus 1. Please find y prime here. Five, 4, 3, 2. All right, I'll calculate it slow because it's quotient rule. 5, 4, 3, 2, 1. Okay, so low d high minus high d low over low squared. So that's going to be 6x, that's going to be 6x, that's a minus, there's plus 3, so it tidies up to 2x plus 1 squared. Okay, no, you don't have to tidy it up, but A, multiple choice will have it in its tidied up form, not this, and B, when it comes time to set derivatives equal to 0, you're going to want to be tidying these things up. Okay, so how about this one? Y equals x squared plus 3x minus 2 over x. What are you thinking about here? Five, 4, 3, 2, 1. Well, y prime, low, d high, minus high, d low, over low squared, or break this up into x squared over x plus 3x over x minus 2 over x, and so that becomes x plus 3 minus 2x to the minus 1. And so in this case, y prime is 1 plus 2x to the minus 2. 1 plus 2 over x squared. And that's a lot less than all that. So it's nice when we can break this up, but most of the time we end up using quotient rule. That's not going to be an option. So you definitely need to know quotient rule. I guess if I were tidying this one up, I would say 2x squared plus 3x minus x squared minus 3x plus 2 over x squared. And so then I could get x squared, these cancel, plus 2 over x. Oh, sorry, that's a squared. And so then I see x squared over x squared plus 2 over x squared. And so I get 1 plus 2 over x squared. And so it wasn't so hard to get them. All right, what's next? How about this one? Y equals x squared plus 1 over 3x minus 2. Please find y prime. Five, four, 3, 2, 1. Okay, so let's use the quotient rule. Low d high minus high d low all over low squared. Okay. Hey, what about this one? Y equals 2x plus 1 to the 1/3 times 3x minus 4 to the negative 2. Please find y prime. Okay, so, oh no, we can't do these yet. That's why. Never mind, take it back. Not until chapter 4. I know you're wondering, what was it about those problems? You'll see in chapter 4. Instead, right now, what I want to do is I want to give you a table with x, g of x, g prime of x, f of x, and f prime of x. And at x equals 3, this is 1/2, this is -7, -2, 4. So I want you to find the derivative in each of the following cases. 1. H of x equals 3x squared minus 5 f of x. Now, this is an example of a place where lots of students want to use the product rule, when really they should just say the derivative of the function times the constant, because inevitably they blow the product rule here. Okay, so here I'm going to say h prime equals 6x minus 5 times f prime of x. So if I want h prime of 3, that's going to be 6 times 3 minus 5 times f prime of 3, or 18 minus 5 times f prime of 3 is 4. So 18 minus 20 is -2. All right? That's how this works. So, 2. H of x equals 2x plus 1 over f of x. Please find the derivative here. Pause the video. Oh, I want h prime of 3. Sorry, I'm looking for h prime of 3 in each of these cases. You might want to pause the video and come back when you're done. Okay, so h prime of x is low d high minus high d low all over low squared. So h prime of 3 then is going to be f of 3 times 2 minus 2 times 3 plus 1 times f prime of 3 all over f of 3 squared. Well, f of 3 is negative 2. So I have negative 2 times 2, which is negative 4, minus 2 times 3 is 6, plus 1 is 7, times f prime of 3, which is 4. This is part of that other line, so I don't have to worry about that. All over f of 3, which is negative 2 squared, which is positive 4. So negative 28 minus 4 is negative 32 over 4, and so I get h prime of 3 is negative 8. Okay. How about this one? 3 h of x equals f of x times g of x. And again, I want h prime of 3. Please find h prime of 3. Okay, so this is product rule. H prime of x is going to be f times g prime plus g times f prime. And since we want h prime of 3, we want f of 3 times g prime of 3 plus g of 3 times f prime of 3. F of 3 equals negative 2. G prime of 3 is negative 7 plus g of 3 is 1/2 times f prime of 3 is 4. So I get 14 plus 2, or 16, equals h prime of 3. All right, let's do 2. Oh no, I erased the table. I hate erasing the table. X, G, G prime, F, F prime, 3, 1/2, negative 7, negative 2, positive 4. Okay, so this time h of x equals f of x over g. Please find h prime of 3. Yes, I have to use the quotient rule here. So h prime of x is going to be low d high minus high d low over low squared. So h prime of 3 is going to be g of 3 times f prime of 3 minus f of 3 times g prime of 3 all over g of 3 1/2 squared. Okay, so what can I do with that? That's going to be 2 minus 14 over 1/2 times 1/2 is not 1, people. 1/2 times 1/2 is 1/4. So I have a 1/4 here. So negative 12 times 4 over 1, or negative 48. Okay. And last one, how about h of x equals g of x over 2x plus 1. Okay, so 2x plus 1. I need to do the derivative here. That means I use the quotient rule. Low d high minus high d low all over low squared. So now when I want to find h prime of 3, I've got 2 times 3 plus 1 is 7 times g prime of 3 minus g of 3 times 2 all over 3 times 2 is 6 plus 1, 7 squared is 49. So g prime of 3 is negative 7. Negative 7 times 7 is negative 49. And g of 3 is 1/2 times 2 is 1 over 49. And so that gives me negative 50 over 49. Done. Table problems. I can pretty much guarantee that one of your AP free response questions is going to be a table problem. Okay, now, if I have y equals f of x, and I talk about taking the derivative of both sides with respect to x, we said that we could write that as dy dx or df dx, but even y prime or f prime. So when I see this prime notation, it means I've taken the derivative of that original y equals or that original f of x function. But what about this notation, y double prime? Y double prime is the second derivative. It's the derivative of the derivative, or the rate of change in the rate of change in a function. Okay? Now, that may seem like I don't understand what you're talking about there, Coop, but don't worry, you will in time. What you need to be able to do is, given a function, take its derivative once, but then take its derivative again. So if this were position, this would be velocity, this would be acceleration. Ooh, there's supposed to be an x there. And we could even do a third derivative, 180x squared minus 48x. That's called jerk. Position, velocity, acceleration, jerk. Fourth derivative, that's called jounce. Position, velocity, acceleration, jerk, jounce. But we can keep taking derivatives, right? We could have y to the fifth. We could even have y to the sixth. Okay? So, second derivative, not a problem. Okay. Will you find f triple prime of 2 given f of x equals 3x squared minus 2x? Okay, so the first thing I need to do is find f prime, which is 6x minus 2, and f double prime, which is 6, and f triple prime, the derivative of a constant, oh. So f triple prime of 2 is going to be 0, because f triple prime of anything is 0. Okay, what about find f triple prime of 2 in this case? F of x equals 6x to the fifth minus 5x to the fourth. Try that one. Find f triple prime of 2. Okay, so f prime is going to be 30x to the fourth minus 20x to the third. And then f double prime is 120x to the third minus 60x squared. And f triple prime is 360x squared minus 120x. And if we want f triple prime of 2, we want 360 times 2 squared minus 120 times 2. So 360 times 2 is 720. 720 times 720, 1440 minus 240 is going to be 1200. All right. Hey, by the way, this is one way for us to ask about taking the third derivative and then evaluating it at 2. But remember, we could also have this other notation. If y equals f of x, the derivative dy dx is the same as f prime. d2y dx 2 is f double prime. This meant we took the derivative twice of y, both times with respect to x. Both times with respect to x. This is the derivative of y with respect to x. This is the derivative twice of y with respect to x both times. So then d3y d3. That's my third derivative. And so if I want to say this, over here what I say is x equals 2. This means evaluate third derivative when x equals 2. Okay? Evaluate the third derivative at x equals 2. Okay, you should be comfortable with these. They're synonyms. You need to be comfortable with all the representations. I've noticed over the years of teaching this class that students who embrace the notation and don't try and hide from it actually do better on the AP exam. So keep that in mind. All right, so here I'm going to give you y equals x to the third plus 3x plus 1, and then I'm going to ask you this question. Show that this y equals satisfies the equation y triple prime plus xy squared, or x double, no, times x, y triple prime plus x times y double prime minus 2y prime equals 0. This is a favorite on the AP exam where they want you to apply this function in these ways to show something. Okay? So I need some derivatives. Y prime is going to be 3x squared plus 3. Y double prime is going to be 6x. And y triple prime is going to be 6. So this is 6 plus x times 6x minus 2 times y prime, 3x squared plus 3. And that should equal 0. Well, let's see if it equals 0. I've got 6 plus 6x squared minus 6x squared. Negative 2 times 3 is negative 6. And lo and behold, these cancel and these cancel. And so, yeah, I was able to show that. Okay, let's do some application problems. Okay, so, how about this one? Where does y equals x over x squared minus 9 have horizontal tangents? I know, and you're probably saying, huh? Look, it's easy. What do you know about the slope of a horizontal tangent? The slope of a horizontal tangent is equal to 0. What's another word for slope? Derivative is a synonym for slope in our class. So what I want is the derivative equal to 0. That tells me where I have horizontal tangents. So that means I have to take the derivative of this function and then find when the derivative is equal to 0. Okay, so y prime is going to be low d high minus high d low all over low squared. So that y prime tidies up to x squared minus 9 minus 2x squared over x squared minus 9 squared, or negative x squared minus 9 over x squared minus 9 squared. I think I did that right. If I pull a negative out of here, I have x squared plus 9. And on the bottom, x squared minus 9 squared. Okay, so now I want to set this derivative equal to 0. Actually, first I just want to check it one more time. low d high minus high d low all over low squared. Yes, yes, yes. Minus x squared minus 9. Great. Okay, so I want to know when the derivative is equal to 0. So minus 1 x squared plus 9 over x squared minus 9 squared. So I set this equal to 0. And now this is a pre-calc problem, right? Because we've done this in pre-calc. X squared minus 9 squared on both sides. Oh, look. The denominator doesn't play any role whatsoever in solving this equation, or finding when the equation is equal to 0. So then I've got negative 9 equals x squared, and I try and take the square root of both sides, and I can't take the square root of a negative number. And then the answer is y equals x over x squared minus 9 doesn't have horizontal tangents, because we couldn't find any place where the derivative was equal to 0. Okay? All right, now please write the equation of the tangent line at x equals 2 to curve y equals 1 minus x over 1 plus x. So what information do you need in order to write the equation of a tangent line? You need a point. They've given us half of a point. How do we find the y value for that point? I have to take that point and plug it into these places. 1 minus 2 is negative 1. 1 plus 2 is 3. Okay, so I've got a point. What else do I need? I need a slope. And the slope is the derivative evaluated at that point. So y prime is going to be low d high minus high d low all over low squared. And remember, we want y prime of 2. So 1 plus 2 times negative 1 minus 1 minus 2 times 1 over 1 plus 2 squared. And what do we get? That's negative 3. Negative 1 times 1 is negative 1. Minus 1 is plus 1 over 9. So negative 2 ninths. So now I have a slope, negative 2 ninths, and I have a point, 2 comma negative 1/3. And so we can say y minus a minus 1/3 equals negative 2 ninths x minus 2. So we can write a tangent line. Remember, in order to write a tangent line, you need a point and a slope. And we can get that slope by taking the derivative, because derivative and slope are pretty much synonyms for us, not synonyms. All right, how about this one? Y equals x squared. Okay, so we know what y equals x squared looks like. And what I'm looking for is find the x-coordinate where the tangent line to y equals x squared is parallel to the secant line on y equals x squared on the interval from negative 1 to 2. Okay, so, wow, there's a lot of words here. I want a line that's parallel to the secant line on that interval. So that interval goes from negative 1 to positive 2, and I want a line that's parallel to this one. But that line is a tangent line, so I'm not going to be looking for something like this that touches twice another secant line. I'm going to be looking for something like this that touches only once a tangent line. Okay? All right, so how am I going to do that? Well, first, I need to find the slope of this line, because I know that parallel lines have the same slope. So I need y negative 1 and I need y of 2. And how did I get those? I plugged -1 in there, I plugged 2 in there. And now I want to use the slope formula, y2 minus y of -1 over 2 minus -1. So we have 4 minus 1 over 3, and I get 3 over 3, or 1. So I know that the slope of the secant line is 1. That means the slope of the tangent line must be 1. So if the slope of the tangent equals 1, that means that dy dx will equal 1, because slope and dy dx are pretty much synonyms for us. So what's dy dx going to be? Well, y prime is 2x. So I'm wondering when 1 equals 2x. And if I divide both sides by 2, I get x equals 1/2. X equals 1/2 is the place where y equals x squared has a slope of 1. See, this is 1/2. But I'm supposed to write, just find the x coordinate. There's the x coordinate, all done. Okay, so I had to find the derivative and set the derivative equal to the slope of the secant line. How about this one? How about, I'm done with those. Well, those are good questions. They're very good test questions or AP questions. So think about them. How about this? F of x equals 3x squared for x values less than or equal to 1, and ax plus b for x values bigger than 1. And we're told find the values of the constants a and b that make f differentiable at x equals 1. I think this is a great question. You know, it better be on our next test, because that's just perfect. Because it gets a little practice with derivatives, but it also has us remembering about differentiability that we talked about earlier in chapter 3. So in order for the function to be differentiable at a point, we said two things have to be true. First, f has to be continuous at x equals 1. And 2, we know that the limit as x approaches 1 from the negative side of the function needs to equal the limit as x approaches 1. Not the function, but the slopes of the function of f prime. So I need the limit of the slopes to be the same from both sides. Said a different way, the derivative of this should equal the derivative of this at x equals 1. And in order for the function to be continuous, not only does the point have to exist, f of 1 is 1 squared times 3 or 3, but the limit of the function also has to exist and equal 3. So if I put 1 into both of these, I should get 3. Okay, so let's apply that knowledge then to find the values of a and b. First, we know that 3 times 1 squared should equal a times 1 plus b. This is us checking to see that the limit as x approaches 1 from the positive side of f equals the limit as x approaches 1 from the negative side of f equals f of 1. Okay, that's us doing continuity. And so here we can say that 3 equals a plus b. But now I'm going to look at the derivative of each of these. And so I've got 6x should equal a, right? Because look, the derivative of a constant is 0, and the derivative of this linear function is just its slope. And what did we know? We know at x equals 1. So a equals 6 at x equals 1. A plus b equals 3. So 3 equals 6 plus b. B must equal -3. So when a equals 6 and b equals -3, f is differentiable at x equals 1. Because remember, differentiability implies continuity. Okay, so how about this one? F of x equals x squared for x less than or equal to 0, and x to the third for x greater than 0. Show that f prime of 0 exists, but that f double prime of 0 does not. Okay, so in order for f prime of 0 to exist, I know two things. First, this function needs to be continuous at x equals 0. So the limit as x approaches 0 from the negative side of the function, that means I plugged a 0 in there, is 0. And the limit as x approaches 0 from the positive side of the function, I plug the 0 in there and get 0, should equal f of 0, which is 0 squared, or 0. So because the limits on both sides of 0 of the function f are equal to f of 0, I know this function is continuous at 0. Good. Well, what's the other requirement for differentiability? Well, the derivatives need to be equal. The limit as x approaches 0 from the positive side of f prime should equal the limit as x approaches 0 from the negative of f prime. Okay, so the derivative on this side is 2x. Oops. The derivative on this side is 2x. The derivative on this side is 3x squared, but we want to evaluate these derivatives at x equals 0. And what do we get? Over here, we get 3 times 0, or 0, and over here we get 2 times 0, which is 0. So we could show that f prime of 0 exists, because, in fact, we could even write out a nice nifty justification. We could say f prime of 0 exists because f is continuous at 0 and the limit as x approaches 0 from the negative side of f prime equals the limit as x approaches 0 from the positive side of f prime. That's great. Now we're supposed to show that f double prime of 0 doesn't exist. All right, so let's see if we can do this. We said that f prime would be 2x for x less than or equal to 0, and 3x squared for x greater than 0. And now I want to show that this does not exist. Okay, so first, continuity. If I plug in my zeros, I get 0 equals 0. So I'm good on continuous. But what about differentiable? What can I say about the limit as x approaches 0 from the negative side of f double prime? F double prime represents the slopes, or taking the derivative here. What's the derivative of 2x? 2. Now what about the limit of the slopes from the positive side? What's the derivative of this? 6x. And where do we want to know this? At 0. 6 times 0 equals 0. Since the limit as x approaches 0 from the negative side of f double prime does not equal the limit as x approaches 0 from the positive side of f double prime of 0 does not exist. Nice question. Okay. And if you're not feeling comfortable with these things, you need to be asking more questions. You need to be getting yourself comfortable, because, yeah, that's where we are. All right. Have a great day, everyone.